Um, Hello, everyone. Thanks, Richard, for the introduction, and thanks, NBCO, for the invite. I'm going to talk about timber frame construction. It is an MNC. It's a modern metal construction. It's one that's been around for a bit longer than the rest, and I'm going to concentrate on it from a building control point of view. Okay. I'm just going to bring you through. Oh, even better. I'm going to bring you through. Just going to talk a little bit about the history. Talk about timber frame in Ireland, how it compares to traditional. The big concerns we all have with timber frame, the codes that govern timber frame, the building control, what we have seen certainly in Fingal and our observations. What's next for timber frame, and maybe round off with a few top tips. On timber frame, it's not new. It's been around. It's probably one of the oldest methods of construction in the world. So it's been around for thousands of years. It lost its popularity, believe it or not, towards the end of the Georgian era because a lot of the wood, certainly in the UK and in Ireland, were hardwoods, and they were perfect for building boats. So the timber frame wasn't as popular. What really done it in was the Great Fire of London, 1666, and King Charles II, so the previous King Charles, he basically said no more. 80% of London got burnt to the ground. He said no more timber frame. All buildings have to be built out of non-combustible material, hence the term non-combustible material. So it was basically brick and block from then on in the UK and in Ireland. And we're quite unusual now because most of the rest of the world builds with timber. In the UK and Ireland, we are still predominantly building with block and brick. In fact, in London, it was the only timber frame that's been allowed, or the first time timber frame was allowed back into London was in 1997 when they reconstructed the Globe Theatre in Southwark. So, we're both Ireland and England we've always traditionally been opposed to timber frame, and possibly it does go back to the Great Fire of London. But timber frame has been around a long time, and timber frame does work. Here's a temple in Japan, and it's more than 1,300 years old, timber frame. So, it is a product. It has been around a long time. I suppose Ireland and England, we're a little bit worried about it and have always been a little bit worried about it, and particularly from a fire point of view. What is timber frame? Okay. And these terms here are probably the terms you're going to hear on site more than what you will see in literature. When you're on site, you're talking to the builder. Stick form or stick build, nobody uses that. Okay, that's just building it from scratch. That's bringing all the lumber on the site and actually hammering it all together. Maybe it was used in the noughties. It probably was used in the noughties. Probably part of the problem. What you will see on site most of the time is open panel or platform, okay, where they're doing one floor at a time. And the builders typically call open platform or open panel. They say that in their mind, it is the timber frame structure with the insulation, with the VLC, the vapor control barrier on one side and the breather on the other side. That's what they would normally consider as open panel. You can get closed panel as well. From the developer or builder's point of view, closed panel is generally everything is there, windows, the whole lot. Now, most of what happens in Ireland is open panel. It comes in the bits and it's put together on site. There's volumetric as well, was mentioned earlier on. Haven't seen much of this, haven't seen any of this in Fingal, but it's there, the 3D. Like I said, currently nationally, these are the figures from the BCMS from 2020 to 2024. 22.71% is timber frame nationally. So it is out there, I guess 1/5. In Fingal, it's higher. In fact, I would estimate it's actually, that's over the last 4 years. It seems to be very popular in the last year. And an awful lot of the building sites are using timber frame. Why timber frame? These are all the items that seem to encourage timber frame. The big one is speed of construction. When the timber frame arrives on site, it can be put up in a day, one day. Suddenly it's there. There's other benefits that the builder sees, less wet trades, cleaner site, especially with a current skills shortage, with not the same amount of access to bricklayers. The off-site manufacturing, it's a lot of builders like this. It's built off-site and it arrives in ready to go. I know there was a lead-in mention. I think it takes 6 weeks to build a timber frame off-site, so it's a bit unusual. You could have the timber frame could be nearly built off-site when the commencement notice comes in. So you're kind of wondering, BCAR, it actually commenced, 4 weeks ago. It just hasn't commenced on site. So, is there an issue there? Should we be in the timber frame factories? It's probably no harm to go in and pay them a visit. Do we have a role? Maybe not. They're producing a product. It's a construction product. It's arriving to site. It's certified. Maybe not. I don't know. Timber frame, high levels of insulation. It's wood and insulation. So you're not going to have the same, issues. There's no thermal mass. It'll heat up really, really quickly. Environmentally friendly, waterproof quickly. I threw it in there. Typically you would waterproof a timber frame house really quickly because moisture is not good for a timber frame house. But, if you're building it in a day, generally they get it waterproof the following day or later that day. Less site waste. One interesting one, factory controlled and erected by trained staff. A lot of builders love this. It's factory controlled and it's erected by the supplier's skilled personnel. So they just step back and let the timber frame arrive on site. The erectors arrive on site, they get the crane, they lift it all into place, and then they sign off to say it is completed in accordance with the IS 440 or the agreement cert. Like, the builders love that. It's just, they've moved from not having something to having a building in place, and all they have to do is put the facade on it. Big concerns with timber frame structure. It's a little bit lighter than concrete. We're heading into, climate change is affecting the weather patterns in this country dramatically. It's going to get windier. There's going to be more intense rainfall. Could it, if a timber frame if it's not erected correctly, if it's not bolted down correctly, could it move? Fire is one that, certainly in building control terms, and a lot of building control personnel are experts on fire, and it's one that does worry us. There has been timber frame fires. This is Peckham Apartments back in 2010 in England. This one here is a more recent one. This is Worcester 2019, so it is quite recent. And as mentioned earlier, we have our own in Newbridge 2017. So fire and timber frame don't work very well together if the system is not built correctly. Damp, that's an obvious one. It is timber. Damp is not going to work well. If you're in a timber frame house and you see this in the corner, you are in real trouble, because when you pull all that back, you could be looking at a rotten timber frame, and the timber frame is the structure. And suddenly you have a building that a structure has been compromised. Sound historically has been one of the timber frame problems. I didn't have a picture for it, but certainly in anything that was built in the noughties, apartments built in timber frame in the noughties, I know in Fingal we were tormented with sound complaints. Last thing, it's complicated enough, timber frame. Now this is just a snapshot, is a diagram. Actually, it's an agreement cert that's withdrawn, so it's actually out of date. But it just goes to show you how many bits are in it. There is so many bits in a timber frame construction. It is complicated, and maybe having it produced off-site in a manufacturing process and delivered on site and erected by professionals is the only way to do this, because if you're building that from scratch, stick built, you really, really want to know what you're doing. The codes, I'm going to mention the codes. I'll run through the building regs. Just where timber frame is mentioned, I'm going to mention IS 440, but I know my colleague coming on next is going to talk to you in more detail, and I'll mention Irish agreement certs as well. So I'm just mentioning where timber frame is mentioned in the building regs. It mentions Eurocode 5 and it mentions IS 440. So, they're the two. That's really what A does. And you know how we use the building regs and the technical guidance. They generally tell us how to do it, With timber frame, they kick you out, you know. If you want to build, you can't use the TGD really for A. It kicks you out. So you're either using the Eurocode or IS 440. Thankfully, 99% use IS 440. It is a good manual. B, it is mentioned quite a bit. Timber frame is mentioned quite a bit. So volume 2 solely deals with buildings under 15 meters in height. However, if you have a large and unusual dwelling, it's supplemented with volume 1. I never really liked the 15 meters. It seemed to be an unusual term. I much prefer the term 10 meters, a floor higher than 10 meters. But anyway, so what does it say in B? It says if you're going to build a 4-story, you have to put in a sprinkler system. That's what it says. So if you're going 4-story or higher, it has to be a sprinkler system. Separating walls. Separating walls are meant to be non-combustible, except for timber frame, you know? So, but it has to be built in accordance with IS 440 or an Irish argument cert. No services through a separating wall. Separating wall has to be intact. In fact, according to IS 440, separating walls must actually, according to the supplemental guidance that the department released, separating walls have to be built in the factory and have to arrive on site intact. So the separating wall is sacrosanct. It cannot be interfered with. It must go from the bottom to the top. It must protect from fire from moving from one to the other. You have to get your 60 minutes. Supplemental guidance, yeah. So it has to be built in the factory and it arrives on site intact in accordance with IS 440. Just a little bit more. This one's a general one. It doesn't just apply to timber frame, it applies to them all. But the separating wall, like I said, it has to be, it's your protection to stop fire from moving from one building to the other. So if you're going to have battens going across, they have to be less than 25 mil, and they have to be embedded in a fireproof material. But it applies to normal build as well. Cavity barriers, and I put up the list there. That's in as accordance to TGDB Part B. I suppose the big one is D, around all openings, windows, doors, vents, service boxes in frame construction. Okay, so cavity barriers play a much bigger role in timber frame, and you see it on site. It goes around all the windows and all the. Oh yeah, V2. I prefer that terminology. 10 meters above, any floor above 10 meters cannot, if you have a building with any floor above 10 meters, it cannot be made from timber frame. So in Ireland, we don't allow combustible material to use in any building that has a floor greater than 10 meters in height. So, and I don't know whether the new code will replicate that, but it is quite a strict regimen in Ireland, and because of that, we don't see tall timber frames in this country. But maybe we're being overcautious. Moving on, E, timber frame is mentioned. It has its own wall type in E. And there was historic serious sound problems. And it goes into quite a bit of detail about, how dense the material has to be so that it can absorb the sound. And there's 2 types in it, and there's plenty of diagrams. If you use the wall type that's described in E, you can follow the standard testing protocol. If you don't use that wall type, you must sound test every single dwelling. L, it's not mentioned much, but it does mention that air permeability in that paragraph. It talks about sealing the vapor control membrane for all timber frame constructions, and it is a good way to get the air tightness into a building. And then it mentions the repeated timber frame. You'll have the repeated thermal bridge in a timber frame. IS 440, I'm not going to mention much on, but I'm just going to throw up now. This is not the full list of things that where IS 440 kicks in, but it's the main points. Okay, so buildings with the maximum number of stories is 4, and the maximum height of the top level is 10 meters. So this is where it kicks in. And obviously no wall is greater than 60 minutes in air fire resistance of greater than 60 minutes. And the outer leaf has to be either, block or timber cladding, but it must have a ventilated, drained, and I'll come on to moisture in a bit. The best thing about IS 440 is it has to be signed off, and it says it in the code. It has to be signed off. So you're signing on the manufacturers, the provision of a certificate saying that the timber frame structure has been completed in accordance with the timber frame manufacturer's instructions and the requirement of this standard. It is signed off. The builders love that. Building control love this. It is signed off. Timber frame construction is signed off. Things that are not covered by they should be covered by the building regs, but things that are covered by the building regs but are not in IS 440. So you have the Irish argument certs. So there is Irish argument certs out there for timber frame construction. You have the 3D. It has its own, because IS 440 wouldn't cover that. And then you've got other timber frame, that is speciality timber frame, which isn't covered by IS 40. They went down the Irish argument cert instead. So there is other ways to get certification. So in Fingal, what our concerns will be from a building control authority point of view. I suppose the biggest concern is that we don't have another Celtic Tiger issue with timber frame. It was one of the big problems in the Celtic Tiger. Certification is a great thing. It is helping the timber frame industry. It is helping the developers like this, building control like this, having things certified to IS 440, a standard code. It's lovely. This is how you're meant to do it. Follow the code. You get your Irish argument certs for non-IS 440 now. And I know NSA or I were here earlier, but there can be a lot of argument certs, and you can't be an expert of every single argument cert, whereas you can be an expert, you can be good at one code. Building regulation versus certification. Like at the end of the day, we're building control authorities. The building regulations is what the compliance has to be. So we're making the call against the building regulations, and we're using whatever certification we can to make that call. But the building regulations trump everything. If we are not happy that it doesn't comply with the building regulations, the builder needs to demonstrate that it's going to comply. This is the big problem, and I think it's been referred to a few times already. Who does what? This is where it falls down. This is where it comes apart. Does the supplier manufacture and erect it? Does the supplier just manufacture, supply it to the site, and the builder's guys go in and erect it? Or does the supplier manufacturer erects a bit of it, and then the builder's guy erects the rest of it? This is the problem. This is where this is coming unglued. Something gets left out. There's very good details. There's very good drawings developed by the timber frame manufacturing companies, and they go with the products. And on the drawings, it says who fits what. In my opinion, the more the timber frame company and its trained erectors put up, the safer this is going to be, and the better the product is. Practical versus theoretical. If we get to site and we see something wrong, if we get to site and we see something that might make sense, very often we get a situation where, well, it doesn't say that in the cert, so we're not doing it. Sometimes, a bit of common sense, we're just suggesting you do something here. It makes sense, doesn't it? Yes. Why don't you do it? Well, it doesn't say it in the cert. It can be annoying for a building control authority, we see a weakness, something that could possibly go wrong, and sometimes the certs are used against us as a weapon, and that's not the way it's meant to be. We're trying to improve everything. What does Fingal see when it's out and about? What problems, what concerns does it have? Anchor straps. These are really important, and they have to go in on a regular basis. An IS 440 or the Irish argument cert that's supplied with that will tell you how often these have to go in. They're really important. Wall ties, another very important thing. They have to go in at the right spacing. They're made of steel. They're to the right ISEN standard. They have to be bolted onto the timber frame structure, not into the OSB, onto the actual structure. They're critical. Without that, the outer face hasn't got anything to say on. This isn't really a timber frame thing. Open web, posi joists, but it's become so popular, And, the strong back, which is, I have a laser, the strong back has to be vertical. It has to stand up, not flat. They're constantly doing that with the strong back, and that's not a strong back. This is it. It's in the right place. They constantly put it on the flat. It's designed to be a particular way. It has to be put in that way. But this is, you've got open web joists arriving in after IS 440 was written. We've now got somewhere where the fire can move. I'd be very interested to see, does the new version of IS 440 have any concerns about open web joists? Part B, like I said, all the OPs, the cavity barrier has to go around all the OPs. So it's either the red sock, as the lads in site say it, or the timber going around the window. So it's critical. The cavity barrier has to be in compression, or this one here, it is in compression, but obviously the builder's installing that, not the timber frame manufacturer. So the builder's just installing it as he goes, which, this is a recipe for disaster, but it needs to be in compression. Fire stopping, you have to achieve your 60 minutes on the separating wall. You have to fire stop any penetrations through, a modified 30-minute floor. Holes in the fire resistant wall, same again. You have to repair any holes. Eave boxes, this is an old one of mine. I just give out about eave boxes. The eave box, it needs to be fire stopped as well. It seems to get missed over and over again. And separating wall, can't stress it enough, has to be intact. C, here's a picture of a separating wall, quite damp looking, not looking very good. What went wrong? Was it stored wrong in the manufacturer's yard? Was it stored wrong on site? Or was it put in place and then the building was not weatherproofed quick enough? The builder, unfortunately, continued on. building. We made him take it all down. Moisture and timber don't go well together. Weep holes. These are important. This is how the water gets out of that ventilated cavity, especially with brick. And there's a fascination with brick at the moment. Brick is like a sponge. Water goes straight through brick. But weep holes are so important. I have a particular issue with IS 440 at the moment. It doesn't mention weep holes above windows or doors, but you need weep holes above windows and doors. I think IS 440 would say something along the lines that you must have a system in place that makes sure that the water gets out. So to me, that's weep holes. DPC, DPM, like the DPM, with timber frame, the DPC and DPM are absolutely crucial. You cannot have the timber frame touching concrete. If it touches concrete, it's going to get wet. If it gets wet, it's going to rot. It's as simple as that. Here we have a DPC, but 150. He followed half the diagram correctly. He put the DPC 150 mil off the ground, but the timber frame is actually below that because it's level axis and the timber frame is actually below that. So he tried. This is the diagram. So he tried to do. He did the DPC at 150 mil above the ground level, but unfortunately this timber frame is down there. So what's to stop the water that's coming in through there getting over to that timber frame and then rising up in that timber frame? So, this is a common issue. It's Part M driven, in all fairness. The threshold has to be level axis. And because the threshold has to be level axis, it's really hard to get this 150 mil. It's really hard to get that 150 mil because of the level axis. But we need, with timber frame and moisture don't work. It has to be there. Part E, there is a standard, there's a wall described in Part E for a timber frame. There's two types. If you're using that, you can use the testing that's described in Part E. If you're not using that, you have to test every building. Part L, insulation. Here's a house in Fingal, and it's fine. And this is in the floor, and we see this a lot in the floor. Where you have the wall coming up, the floor, and then the next wall coming up. So the top of the first floor, top of the ground floor. The design had insulation in here. But when the building control inspector took a look up in the attic, or he had a concern because he saw what they were doing, and he got them to cut a hole in the ceiling. And when he looked up, there was no insulation. This is what was meant to be in. So there was 25 houses to be done. Most of them were occupied, so the builder had to go back and do all 25. He tried to argue that, you know, with that there, it was still greater than the minimum of 0.6, but he wasn't going to be able to show his deep calculation was never going to work. He was cornered one way or another. So in the end, he just bit the bullet and went back in and installed insulation on the first floor at the cassette for every single building that was built so far. What's next? And I'm going to concentrate on timber frame for the moment. There's lots of different types of timber frame stuff or timber frame materials that could come into the market. We've got cross-laminated timber, CLT. It's stronger, lighter. It's glued together. I don't know, would our fire colleagues be very happy? How does that react in fire? We have nail laminated timber, so the nails hold it together. Dowel laminated timber. You can see a theme here, can't you? Dowel laminated timber. Mentioned earlier, glue laminated timber. This could be very popular. You know, you can use this to build any type of timber structure you want. And like here, you can add on the bits and pieces so that when it's lifted in place, it's ready to go. SIPs. SIPs have been around for a while. I haven't seen many in Fingal. I've always been a bit worried about them because I don't know how they're all going to comply. You know, the possibility that they could come in, they could still come in. You know, I haven't seen very many SIPs in the organization, or in certainly in Fingal. And I suppose the one, and it's not timber, but the one that if I were a betting person, I would be saying this could be a big one. Like edge steel. Any of the sites that I went on to recently, talking to developers that are using timber frame, were saying that they're going to like edge steel next, and they're inquiring about it and they're wondering about it. Now, that's fine. I would love if there was an IS 440 for like gauge steel, because that would make it so much nicer. Instead of having an argument search for every single different type of manufacturer that's making a light gauge steel, which is probably the direction they're going down in. But yeah, light gauge steel seems to be something that's getting very, very, certainly the developers are talking about it and talking. Now, I don't know what the interest is. I don't know what the driver is. Is it cheaper? Is it quicker? I don't know. But certainly developers are really looking into light gauge steel. Top tips. I suppose I mentioned it already. The two biggest weaknesses of timber frame: fire and moisture. You know, if the industry just can make sure we don't have an issue with fire and moisture, you know, we have it. And fire should be straightforward. The separating wall is coming from the manufacturer. You know, it should be fairly straightforward. It shouldn't be an issue. Moisture, it just needs the person on site who's putting in the DPC, the cavity barrier, putting in the weep holes to know what they're doing. IS 440, it's a good thing. It's a good code. Came out in 2009. It is a good code. It has helped the industry. It has helped building control authorities understand what's needed. Two worlds collide. This is where I see the problem. This is where the problem seems to be. You know, who does what on site? You know, you've got a manufacturing system and a builder. You know, where does it move from the manufacturer does it to the builder doing it? You know, this is really where we've had a lot of issues, is where, you know, the builder didn't know that they were meant to put it in, or the builder didn't put it in correctly. Competency, you know, that's an easy one. What I've seen, certainly from site visits, is if the manufacturer is using trained erectors to put the stuff on, and they put it all on, they put on all the cavity barriers, they put on everything, it's done really, really well. You know, so competency, the person installing this has to know what they're doing. Cavity barrier I mentioned before. So, you know, there's a lot of cavity barriers in timber frame. Watch for damaged panels. You know, they do get damaged in transport. If a vapor control layer or a damp-proof layer is damaged, you know, you have to remember that's stopping the moisture from inside the dwelling getting into the timber frame structure. it could cause a lot of problems. There's a lot of moisture inside a dwelling. Yeah, product is, you know, the builder, the developer, and the timber frame manufacturer need to be on the same page here. You know, if they're going to measure it on site and order it, you need to order the right size. If they order the wrong size and it turns up on site, you know, if you turn up on site and there's a chippy banging in bits of wood to try and get one piece of timber frame to meet another piece of timber frame, we're in real trouble. Mentioned this before, DPM, DPC, absolutely critical. You know, the timber frame has to be kept away from moisture. In so much that, you know, in the separating wall, there has to be a little channel on the bottom of the separating wall to let the moisture come out. So moisture and timber frame do not react well. And I would advise anyone, all building control authorities should have a moisture meter and use it. You know, you can buy them for about 40 quid, 50 quid. It mightn't be a brilliant moisture meter, but it might be enough for you to put it into the timber frame, hit the button and say, can you get this checked? You know, you're not saying it's over 18%, but you're saying you have a concern. I recommend that everyone should have a moisture meter. They're so cheap. And when you turn up inside with a moisture meter, before you know it, the builder will have his own moisture meter. Final thoughts. Timber frame industry has come on a long way. It is so much better than the noughties, okay? So it's getting there. I think IS 440 had a lot to do with it, but it is getting there. And that makes me worry about all the other modern method construction. Are they going to go through a noughties situation where they're a disaster before they actually get there? Climate change mentioned earlier, we have to be cognizant of this. You know, the weather is getting more intense, and that's really it. More intense rainfall, more intense wind. You know, you're building for 60 years. It has to be built for 60 years. It has to be able to take it. Thankfully not in Ireland, it's in America, but timber frame damaged by storm. So something was wrong there, you know, either it wasn't designed correctly, it wasn't fit for purpose correctly. Competency of designer, manufacturer, installer. You know, the designers are generally in the timber frame manufacturer, they're part of the team. I've seen some of the design drawings, they're brilliant. The manufacturer, you know, we're relying a little bit on NSAI and the factory production control. I would recommend, if you have a timber frame manufacturer in your area, it'd be no harm to call in, even just to say hello, you're the building control authority. You know, there might be some sort of exchange there that might benefit both of you. It's the installer. The installer is where this is going to fall apart. You know, is this guy a designer, and a science certifier, or a builder? He's in trouble anyway. So really, the installer, the competency of the installer. If you turn up the site and you see these guys, you're in trouble. These are not good installers. They're obviously not fit for purpose at all. So that's. Oh yeah, I wanted to mention this. I think someone mentioned it earlier on. This is. I just came across this on the web and I thought it was fascinating. This is a fold-up house. You know, so it arrives to site and all you need is a crane and it's all hinged and you just unfold it and then it's a house. So chances are, I hope there's not someone in looking for an agreement search for this one already. But I just thought, oh my God, is this the direction we're going? So look, thanks everybody. That's it for me.